All right, this is example 5.1.2, and it says construct and label a force diagram for the following picture, which shows a truck accelerating to the right. So we have our object, which is the truck, and we say, is the truck going to be subjected to gravity? And of course the answer is yes. So we have an arrow pointing downward, and we label that as FG. We say, is the truck in fact moving downwards? And the answer is no, it's traveling along the level road. So we can say there's a force upward, and we call that the normal force. Now, just to make sure that we are correct in how we draw this, we can write out to the side, hey, Fn equals Fg. And that lets whoever's reading this free body diagram say, oh, okay, those arrows are supposed to be the same length. So now we say that the truck is accelerating to the right because it is going to have some sort of force directed to the right. That's the force of the engine, or the applied force. Now there is actually another force that we're going to assume is there, and that's going to be friction. Now friction could be friction between the tires and the roads, it could be air resistance. A lot of times we neglect friction, but friction is really important when we talk about free body diagrams. So since it's fairly obvious right here that the applied force is greater than the frictional force, and the reason for that is the fact that the truck is in fact accelerating to the right. But if I wanted to make sure, I could actually write FA is greater than FF. Now I highly recommend that you do this whenever you're drawing free body diagrams, because it makes it so much easier for me to look at it and say, okay, that's what they meant to do. Sometimes whenever you just say, if you didn't have this Fn equals Fg, and I were to measure these, I'd say, well, you know, the Fg is a little bit bigger, maybe they meant for Fg to be larger. So it's very important that you qualify what you've drawn by saying, okay, this is what I meant. Either that, or you make it so obvious like we did here that there's no room for error.